All right, so now what we're going to talk about are formula masses. And it is just a tiny, tiny bit of math here in formula masses. Just a tiny bit, just a little bit. And if you're ever Googling this sometimes, you'll see some folks online who use the term weight, formula weight. I don't like that word. A few years ago, as chemists, we kind of got together and decided that was not a really good word to use. It's just like sort of the average atomic mass thing. You sometimes hear average atomic weight. It is out there. It means about the same thing. So formula mass or formula weight tends to be the same thing as what people are referring. And what this is this is the sum of the masses of the atoms in a formula. So literally all we're going to do here is summation. Now eventually this is going to involve us going into using PEMDAS. Good old, please excuse my dear Aunt Sally, but it's only those high-level questions, those very tip-top. So you can imagine, if you're doing this, if we take a formula of something like gallium nitride, right? So I know the name, I know the formula of this compound, very, very common compound. But anyways, to find the formula mass of this, what we're going to do is we're going to take the mass of gallium, right? So we got to look over here on the periodic table, and there is the mass of... do not cancel anything. Do not cancel anything. If we are going to find the mass of gallium, there's the mass of gallium right there. It is 69.72. My decimal a little more visible there. 69.72. And summing means adding, so we are going to add to that the mass of nitrogen. So there's the mass of nitrogen right there is 14.01. So we add those two things together. If you need to, you can reach over and grab your handy-dandy, trusty-dusty calculator. You can have this version of the calculator, or you can have this version of the calculator, or you can use the one on your Chromebook. It does not matter. And we punch those numbers into our calculator. Sounds like I'm angrily punching them into my calculator. But what we should get, if we do this correctly, is we should see it's 83.73. And the units that we put on there, these are AMUs. If you remember, the average atomic mass is always in units of AMUs, or atomic mass units. So we're going to, right now, we're going to find out later on that there's a better unit that we're going to use for these, but for now we'll stick with AMUs. And so that is the answer to that one right there. So now you try one. You try one. I'm going to give you one. We're going to do lead 2 sulfide. If you're going to try it out, pause right here. Great. Hopefully you looked over here and you saw that lead is 207.2. 0.20 actually, but you know, we'll leave off the 0 for now. Sulfur is 32.07. And so when I add those two together, I get 239.27 AMUs. Easy peasy, right? Gets a little trickier when we introduce subscripts. So if I want to look at something, for example, like Gallium Iii Oxide, it looks like this. So now what the heck do I do? If you've got a guess and you'd like to pause it and you'd like to try that out, pause here. And what we're going to do with this is now this means we have 2 galliums. So we could just add galliums, right? We just go ahead and add 2 galliums. Or we can do it slightly easier way, would be if I take the mass of gallium, 69.72, and I multiply that by that subscript, right? So we got the gallium goes there. The 2 goes as a multiply by 2. Plus oxygen is 16.00 times 3 oxygens. Gives me, now this is one that I can't do in my head, so I'm going to angrily punch this into my calculator. I hate doing math. I thought this was a science class. Shouldn't I be doing math in science class? I can't believe that. Why are they making me do math in science class? and I get 180. Ooh, I'm going to run out of room here. 187.44 AMU. I can squeeze an AMU down here. There we go. Cool. So how do I make things even trickier? Well, let's make it slightly more trickier, and let's look at something that has more than 2 elements, for example. So if I have AU, which is gold, gold 3 sulfate. So hopefully you look at this and you have the immediate reaction of, ah! Right? Which is a good reaction to have when you're looking at this. I hope I didn't really scare anybody with that one. But the first part is pretty simple. What we need is we need gold. I've got to look over here. I've got to find gold. And there's gold right there. It's 196.97. And the subscript on gold is 2. I'm going to leave this so I can still see those other ones up there. So we're going to multiply that gold times 2. And to that, we are going to add, well, shoot, I've got all this, right? What do I need to do? Well, I'm just going to write it like it is. I'm going to open my parentheses out, and I'm going to write sulfur. Sulfur is 32.04, excuse me, 0.07. Let's make that a 7. There we go. 32.07. And there's only one sulfur there, so I don't have to worry about multiplying that one by anything. Plus 16.00 for oxygen. I'm going to have to scooch over a little bit, but now I've got those 2 written down, so I don't need them anymore. That oxygen gets multiplied by 4 times 4. And now I'm going to close my parentheses. And there's another subscript down here, so I just know that subscript means times 3. Your calculator can handle this just fine. It is going to PEMDAS this for me just fine. If you wanted to go through and do the PEMDAS thing, you could, but I don't know why anybody would torture themselves like that. If you do, pause the video now. We'll see if you get the same answer as I do. I'm just going to plug it in my calculator just like this. 197.97 times 2 plus, open parentheses, 32.07 plus 16 times 4, close parentheses, times 3 equals, I get 682.15 AMUs. Now, if I wanted to, I felt, man, this one's way higher than those other ones. If I wanted to check that work, one thing that I could do is I could go pull up Google. I'm going to pull up Google here, and I'm going to type that in, AU2, open parentheses, SO4, close parentheses, 3, and formula mass. And let's see if Google comes up. It calls it molar mass, but it gives me this 682, and they give it in a lot more decimal places, don't they? Oh, who needs all those decimal places? I tell you what. On your test, by the way, just to make mention of this, all you'll need are 2 decimal places. So on this one, they got 682.12, and we got 682.15. And so we're freaking out. We're like, oh, they're not exactly the same. And this is where the math teachers hate what I'm about to say. Don't tell them this is our little secret, okay? In chemistry, those 2 numbers are the same number. Doesn't matter about that last number, whether it's the same or not. It doesn't really matter, especially for this work, if what you've got after the decimal place exactly matches what I've got. It depends on what periodic table you're using. I bet their periodic table might have been rounded here slightly different, or maybe their sulfur was slightly different, and that's why their numbers are slightly different. They might have used 32.06, for example, and that's why their numbers were slightly different. But this is close enough. If the 682 is good, I probably did the math right. So that's a great way you can check your work. And now there's a bunch more for you to practice on your worksheet.